Hello and welcome to this tutorial on the organization and application of 3D data. In this tutorial, we will introduce you to the basic operations of a 3D scene, the way to organize 3D layers, and the methods to add various data into 3D layers. The main contents of this tutorial include data structure, 3D scene introduction, browsing a 3D scene, 3D layer organization, 3D flying, and 3D applications. Let's take a look at data structure first. This is the most basic data structure of Supermap GIS software. First, we can open various data sets in the workspace. Then, we can add them to 2D layers to organize a map or add them to 3D layers to organize a 3D scene. If the data is modified, the map or scene will be modified as well. The key point here is that all the data sets are stored in one or more data sources, while the map or scene is stored in a workspace, so the data sources and the workspace must be used together at any time. In this tutorial, we will apply different types of data to 3D layers to build some beautiful scenes. So let's talk about a 3D scene. The 3D scene uses virtualized technology to simulate various geographic features and their spatial relationships in the real world. There are two view modes of 3D scenes, a plane scene and a spherical scene. A plane scene is where the surface of the Earth is spread out into a plane to load and display features. PCS or Planar Coordinate System data and Projected Coordinate System data are supported on a plane scene, while displaying ocean, atmosphere, graticule, or graticulable are not supported. Okay, so let's talk about a spherical scene. Now, the spherical scene simulates the surface of the Earth with a sphere. It is covered by global remote sensing images. It simulates the universe, space, and the Earth's atmospheric environment. It supports loading the data of geographic coordinate system and projected coordinate system, and it can control the display and the latitude and the longitude grid, the navigation compass, and frame rate. Let's take a look at it within Supermap iDesktop. So in order to create a 3D sphere, we're going to right-click on Scenes, and we're going to say New Spherical Scene. Now what we can do with this here is that we can take a data set and we can render it onto this complete 3D spherical scene. So let's go ahead and see how that is done. So we're going to select this world image data set right here, and we're going to drag and drop it onto this 3D scene here. And there we have it. It's completely covered by this particular 3D scene. Now, let's take a complete look at it. The 3D scene has this sort of sun in space shining onto the spherical planet. Now what we can do is we can turn the sun on or off. So let's turn it off. So it becomes day at both hemispheres. So let's turn it back on again and let's adjust the trajectory of the sun. So we can use this bar right here to shift the sun where we want it to be. Right, let's turn that off. Also in a 3D view we can have some FPS information. We have a status bar, we have a scale. This here is a compass. Now this compass allows us to move the scene around, tilt and pan it, and zoom in and out of it. Now this is true for all 3D scenes. Like we can use the arrow keys on the keyboard to move the scene around, like we're doing right now. And there are some other shortcuts as well, the details of which can be seen from the help file. So next, let's talk about a bigger 3D scene. For example, a scene that contains a lot of 3D elements. So in order to do that, we're going to open our city model, and we have that right here in our scenes contained within the 3D scene workspace. So we're going to go here and we are going to render CBD. So as it is quite a big 3D scene, it is going to take some time to load. As you can see, there are lots and lots and lots of elements on this scene. So we're going to give it some time. We're going to let our hardware adjust. And depending upon the power of the hardware that we have, it is going to load quicker or slower. And it is going to move around smooth or stuttery. So the hardware that we are using right now for graphics is the mobile version of GeForce GTX 1060. And despite this chip being a very recent development, we can see that it's struggling to keep up with this scene. Now, that is because of the amount of detail included within this scene. Now, this is so detailed that we can go under this flyover right here. So let's try that. So in order to zoom at a specific location, we're going to take our mouse pointer to that location, and we're going to use our mouse scroll wheel to go right ahead and zoom in to that particular point that we are pointing at. So as you can see, lots and lots of detail right here. Now there's a lot of things that can be done in a GIS or planning perspective when you have this amount of detail. Right, so let's talk about how a 3D layer is organized and what elements it contains. So the first thing is a screen layer, which contains static graphics such as logo, descriptions, text, etc. Now the screen layer is static. That means that it does not change with the other layers of the 3D scene. So even if you zoom in, zoom out, tilt, pan a 3D scene, the static screen layer is going to stay right where it was originally. The second thing is the general layer. The general layer would contain 2D data, 3D data, cached data, service layer, and KML layer. Now each of these layers can contain point data set, line, polygon, text, CAD, map, OSGB, etc. Finally, we have the terrain layer that contains terrain-based visual data such as DEM, grid, and terrain cache. Now let's go ahead and add a screen layer to our 3D scene and see how it's operated. So we have our 3D scene right here, this 3D scene that we loaded, the CBD set. So what we're going to do is that we're going to add the Supermap logo in this corner of the screen, right there. So we're going to go ahead and we're going to right-click the screen layer. We're going to say Add Object, and we're going to go into our 3D folder, and we're going to select logo.png and say Open. Now, there we have our logo, but as you can see, I'm unable to edit it right now. That's because by default, we are selecting the elements on the 3D general layers. So in order to be able to edit this, we're going to go ahead and right click on the logo image that we just added, and we're going to enable edit. So as you can see here, there's a small check mark next to it indicating that this object is now editable. And you might also have noticed that we have some lines and pointers on the image now. If I wanted to move this around, I can't do it from just anywhere on this logo image. I have to use these pointers that have just appeared. So if I want to resize, I'm going to go to the edges of this object. Like all four edges will allow resizing. And if I want to move it, I'm going to go right in the middle till the mouse pointer changes like that. So let's say we want to move it first to the top left, just here so we can resize it. And then we're going to resize this just enough so that it looks a bit decent here. Now we're going to move it again right to the top left corner, right there. Now, while we're moving around our scene with the logo here, we don't want those pointers to stay on our object. So we're going to go ahead and right click again and uncheck the edit check mark. There we go, it has disappeared, and we can continue to browse our 3D scene with a screen layer object in place. So let's talk a little bit more about our screen layer object. Now, we said that they are static, like they don't move with the actual 3D general layers. So they can be a watermark, they can be a logo, they can be a label, etc. These four formats are the ones that are supported for them, and they use screen coordinates. They have no geographic meaning, and they will stay static relative to the 3D window as we just saw. So please go ahead and practice this on your own so that you get a hang of it. So now we're going to talk about adding a general layer. We're going to start with the map layer again, as we saw earlier. How to add the map layer into it. We're going to redo this so that you can practice it. we're going to talk about opening a model, which is a BIM file. Next, we're going to talk about an OSGB cache and what it does. We will talk about an image data set. And finally, we will talk about a KML file and what its purpose is. So first, let's go back to our world image. In this repetition, we're just going to add something more to this sphere. Let's say we're going to go back to our world data source and we are going to add a polygon onto it. It is a rough polygon, but it'll give you an idea of what can be done with it. So let's go ahead and grab this world polygon and drop it onto our scene. So you see it starts to take over the currently applied image. Now we're going to move on to our BIM 3D file. Let's go ahead and open up this BIM 3D scene. Now it's a quite large and quite detailed 3D scene. It differs just a little from the one that we saw earlier in that it is detailed on a micro level. Right, so let's demonstrate dropping that onto an empty 3D scene. So let's go ahead and say new spherical scene, and we're going to take our data sets and we're going to drop them right onto our 3D scene right here. We're going to drag and drop. And then we're going to double click any of the data sets and it'll take us right to where that specific data set is located. As you can see, it's literally navigating to individual data sets that we dropped onto our 3D scene right there. So that's our BIM layer. It contains a lot of minute detail, very detailed, just like the CBD layer there. We're going to open up another new vertical scene. And this time we're going to work with an OSGB cache. So we're going to go to general layers. We're going to say add OSGB cache layer. And we're going to go into our 3D folder, OSGB compressed.scp. I'm going to say open. There we have it. Let's double click on that so that it jumps to the exact location of our model here. So there we have it. It's an OSGB cache layer. So let's go ahead and zoom into it and see what it's all about. So what this really is that it's real images of buildings and elements on the ground in order to create a 3D looking scene. Now this is not very detailed. Like if I zoom in further, you're going to be able to see that these are just images stitched together. There, you can get a view of sort of how that works. So all of these are stitched together into a cache layer. That gives us a lot of detail, but in a limited way. And this can be very useful for 3D maps. So let's talk about a terrain layer. Now, a terrain layer might contain a grid or a terrain cache. Now, a grid data set might contain the altitude value. When we drag it into the scene, there will be a reminder asking you whether you want to add it as an image layer or a terrain layer. So let's demonstrate the effects of the two layers. We're going to open up the DEM dataset and we're going to grab the DEM25 and drag it onto the scene. So as we said, it is asking us whether we want it as a terrain or as an image layer. So let's say we want it as a terrain layer. So it has been added as a terrain layer. Double click on that and zoom into it. So when we add this as a terrain layer, we have some altitude, but not really a lot of different color to the scene. Now this altitude that we see here is from the terrain layer, and now we're going to see that we have added the image layer and we can see some different colors. So as you can see here, we have some altitude and the image layer has applied some different color effects to it. So when we disable or enable the terrain layer, the altitude goes away and comes back. And if we disable our general layer, that is the image, the color effects go away. So let's now go back to our CBD dataset and see what 3D flying is all about. We're going to add a new flying route in the 3D scene. We're going to edit it. We're going to start flying through the scene. We're going to decelerate, accelerate, pause, stop, and save it. Right. So here's our very familiar CBD 3D scene of Beijing City. And we are going to create a fly scene through it. So let's zoom out first of all, so that we have an overall view of this 3D model. Right. So here we have an overall view. Let's zoom out just a little bit more. And let's take a look at it from the top here, right then. So we're going to go under Fly Manager here. We're going to say New under Manage. And we're going to click the Add Stop by clicking button under the Flying Stops Manager. So let's do that. Let's say we want to start over here on top of this building. And then we want to keep flying to here. And then as we keep clicking, we're going to keep adding flying stops. And the Fly Manager will follow this path that we create. So number 3, let's have it over here. And then we go on top of this building. And then this one, we go to the corner. And then we keep coming this way to here. And then we turn towards the road. And then maybe we want to fly over the road. So let's make a fly scene through the road. There we go. Another point. Another point. And I think that's it. So this is how it goes generally. But as you can see, it's a bit skewed. So what we want to do to fix that is maybe increase the altitude. So let's accelerate this scene here. Let's decelerate it so it goes slower. Now this is why we want to increase the altitude, because it's going right to the surface. We don't want that. So let's go ahead and edit the altitude. This we can do from here, camera settings, at all the stops. Let's make it 120 subsequently. Okay, that is fine, that's fine. Alright, this one. Let's edit this to 120, 108. Let's make that 120 as well. This one as well, 120, 120, oops, 120, 120 again, 120 again, and 120 again. Right then. So let's go for it. Let's fly again. So there we go. We have a more overview sort of view right now. And it looks much better. This way we can see a lot more elements that we did before. Let's decelerate it a little bit. And let's go ahead and accelerate it again. And let's try and stop this. So when we click on stop, it's going to go back to stop number 1, and we will have to fly all the way from the start, like that. But if you just pause it, you can just resume it from where you paused it. So that's something to keep in mind. Alright then, let's stop this, and we are going to save our flying scene. Let's say save as under our 3D data folder, and we can see that we already have a new scene roots file. So let's call it new scene root, and then let's save it. So what we're going to do is that we're going to open another flying scene, not the one that we just saved, and take a look at the Flying Manager once again. So let's go under open, select the fly routes and say open, then we're going to say fly. So this is where we're sort of following the road in our scene. Let's accelerate that a bit so that we can get through this much faster. So we have our points and the fly manager is going to follow these points religiously. And there we have it. Okay, so let's talk about some of the applications of these 3D technologies. Now what you're looking at here in this slide is an unauthorized construction integrated display system. Now what this can do is that it can help inquire detailed information about illegal construction reported by each city and county. This information includes facts about illegal construction sites, illegal construction units, year of construction, description of violation of regulations, construction progress, structure type, floor space, total area, illegal construction area, total number of floors, illegal building category, and disposal results, etc. So really quite a complete collection of information about illegal construction. Now, through the comparison and analysis of the two satellite images that you see here, the map information regarding any suspected illegal construction will be sent to the city and county for further verification so that appropriate action can be taken. So quite a useful application there for governments. So let's talk about this application right here. This is the application of BIM in the transportation industry. Now, what we are looking at is a project that combines the technology of BIM and 3D GIS to realize the perfect combination of microfine model and macro geographic scene, along with indoor and outdoor integration. It not only has positive support for design and construction, but also lays a good foundation for subsequent operation and maintenance management. Especially at the construction stage, the combination of BIM and 3D GIS can display the whole process of project construction in an intuitive, three-dimensional and all-around manner. It basically uses 3D technology to conduct collision check in the early stage, optimizes engineering design, greatly reduces construction errors, subsequently reducing overall engineering cost. So it provides strong support for the construction of the project and ensures that the product is completed on time and in good quality. Now finally, this here is a three-dimensional visual display platform for a hydropower station. So basically a dam project. Now like the previous project that we saw, this project also uses BIM combined with 3D GIS to achieve supervision of construction progress, production activities, and all equipment outside of the station. So this is how these advanced 3D technologies can help organizations become more efficient, both in cost and resource terms, irrelevant of the size and difficulty of the project. Okay, so that's it for this tutorial on organization and application of 3D data. For more information, please turn to the help document or contact us directly. Thank you.